Page 2, Activity A, Covalent Bonds. Get the gizmo ready. Select the Cold Room tab, show Molecular View, and make sure that water is selected. So you go back here, you go to Cold Room, and you're making sure that water is selected. A cold room is used to find the melting points of substances that are liquids or gases at room temperature. This simulated cold room has a temperature of negative 120 degrees Celsius. Question: what happens to a substance melts? Look at the molecular view of water. What do you see? So in order to see the molecular view of water, you click the little button over here or check mark over here, and now you're looking at the molecular view of water. In the bottom right side of the screen, just describe what you see and write it in 1A. The atoms in each water molecule are held together by covalent bonds. The molecules are held together by intermolecular forces. This is a kind of substance called a molecular solid. In the solid state, do the molecules move freely or are they stuck in position? So when you're looking at this, are these molecules stuck in position or do you see that they're moving freely? Write one of those two options in 1B. Using the gizmo, determine the melting point and the boiling point of water to the approximate melting point and boiling points. You can heat the sample quickly, then run another trial slowly to find the exact temperatures. So what they're saying is you can go ahead and turn it up very quickly and see the exact temperatures for the boiling and melting point. Okay, that went very quickly, so let's reset it. So you're wanting to get these temperatures quickly, and you can see that that's changed, and then the boiling point should also, now you see that it's disappeared. So those were very quickly. You're trying to slow it down. We want to get to around 0 degrees. So when we get to 0 degrees, you'll notice that it changes. You can also stop and slow down the video. And then when we get to around 100 degrees, you'll notice that the water will disappear. That's when it's a gas. So in this one, you'll write 0 degrees is the melting point and 100 degrees Celsius is the boiling point. Do the molecules move around more or less when the water is a liquid? So compared to a solid, do the molecules move more here or when they are a liquid? Write down your answer in question 1D. What you're going to do in this table is change the substances from water to hydrogen sulfide, ethanol, and carbon dioxide. You already have this information. So you write the answer from melting point at 0 degrees right here. Because it already has degrees Celsius, you just have to write 0. And then the boiling point is at 100 degrees. Other transition points, if you see something else that occurs, make sure that you record it in other transition points. So I'll help you out with the next one, and then you can do the ethanol and carbon dioxide on your own. So, hydrogen sulfide. You go up here on the little drop down box. Make sure you hit reset because it won't let you change it if it's going. Pull down to hydrogen sulfide. You can keep the molecular view on or off. It's up to you. Again, you want to start heating it. Keep an eye on the temperature. Notice that it starts to turn into a liquid around negative 68 degrees, or is that negative 67 degrees? I'm not sure. And then you turn it back up, and then around negative 45 degrees, you see that it's turned into a gas. Again, you can slow down the video in order to see that more effectively. So you write those two temperatures. Now if you want to turn it all the way up to see what happens at higher temperatures, to see if there's any other transitions, there are none, so you can just reset and then move on to your next one, ethanol. find out your melting points and boiling points for ethanol and carbon dioxide. When you try carbon dioxide, did you notice anything usual? I would make sure that you have your molecular view on when you're doing carbon dioxide to make sure you catch that. That concludes page 2. Go ahead and turn to page 3.